How does capillary action work in pens? Imagine a tiny river flowing inside your pen, guiding ink smoothly onto your paper. That's not magic, but a natural process called capillary action. When you write with a fountain pen or even some markers, this process makes ink move from the reservoir to the tip. It all starts with two main forces: adhesion and cohesion. Adhesion is the attraction between ink molecules and the inside surfaces of the pen's ink feed, which are usually made of plastic or metal. Cohesion is the attraction among the ink molecules themselves. These forces work together to pull ink through very narrow channels or fins inside the pen. Inside a fountain pen, the ink reservoir holds the ink, and the ink feed contains tiny channels that connect the reservoir to the nib, which is the metal tip that touches the paper. When you begin to write, capillary action pulls the ink through these small channels. The ink molecules stick to the walls of the channels because of adhesion, and they pull other ink molecules behind them thanks to cohesion. This creates a steady, controlled flow of ink that reaches the nib and then transfers onto your paper smoothly. Gravity also helps, but it's not the main player. It assists in filling the feed with ink from the reservoir. Capillary action is what regulates the flow, preventing too much ink from flooding out or drying up. The size of the channels is very important. The smaller the space, the stronger the capillary action. That's why fountain pens with narrow feeds can deliver ink precisely and consistently. Capillary action also works with air pressure. As ink flows out, air enters the reservoir through a tiny vent or air hole near the nib. This airflow stops a vacuum from forming, which could block the ink. Instead, it keeps the ink moving smoothly. Understanding how capillary action works helps explain why fountain pens and many markers write so well. The design of the feed, the ink's thickness or viscosity, and the shape of the nib all influence how well this process works. Thicker ink moves more slowly, and broader nibs have larger channels that let ink flow faster. In simple terms, capillary action is the natural movement of ink through tiny spaces by the forces of adhesion and cohesion. It makes sure ink moves from the reservoir to the paper in a controlled way, giving you a reliable writing experience. That's why your pen writes smoothly and consistently, whether you're jotting down notes or signing documents.